Here is another example to evaluate limit of a function which is not defined at the limiting value. The function is 1 over x minus 1 over 5 divided by x minus 5, and we need to evaluate the limit of this function as x approaches 5. Now, as we had been doing in other examples, now let's substitute the value of x equals to 5 and see what do we get. So if we substitute x equals to 5, in the numerator we get 1 over 5 minus 1 over 5, and in the denominator we get 5 minus 5, right? That is 0 over 0, right? So that is indeterminate form, correct? So basically, whenever the limiting value is substituted and we get 0 over 0, which is not defined in mathematics, is meaningless, then we say that it is indeterminate form. Okay? Now that gives us an idea that we do have a factor x minus 5 in both numerator and in denominator, and that is the reason that we are getting 0 and 0 in both numerator and denominator. Now we'll use simplification of this function, simplify it kind of, so that we can eliminate that common factor from both numerator and denominator. That's the strategy, okay? So let's do that. So we can write this function as equal to limit of the function where x is approaching 5, and in the numerator we will solve this fraction by taking common denominator 5 times x, and we get 5 minus x over x minus 5, right? Now this could be written as limit x approaches 5, 5 minus x over 5x times x minus 5. As you can see, if you substitute 5 and 5, we get 0 over 0. So these are the factors which were making numerator and denominator 0. Now by doing this simplification, we have brought them out, right? And now we can cancel and simplify our function. So what do we get now? We get limit x approaches 5, and the numerator, if we divide by x minus 5, we get minus 1. So we get minus 1 over 5x, correct? At this stage, we can substitute x equals to 5 and find or evaluate the limit of the given function, right? So if we do that, we get minus 1 over 5 times 5, correct? Which is minus 1 over 25. And therefore, the limit of the given function as x approaches 5 is minus 1 over 25. So that is how we can evaluate limit of the functions which are not defined at the limiting point, right? Now let me sketch this and show you how it should look like, right? So basically what we found was that after simplification, function is equivalent to minus 1 over 5x, where x is not equal to 5. So we can write here x is not equal to 5, since the function is not defined at 5, right? What we also saw here was that the limiting value of the function as x approaches 5 is minus 1 over 25. So let's say this is 5 for us, right? Then the limiting value is minus 1 over 5, kind of very close to 0, but somewhere here, right? It is not defined at 5, and since we have a common factor x minus 5 in both numerator and denominator, it cancels out but leaves a hole, right? That's what you've learned. So if we sketch this function, we'll get it like this. You see that? It's like minus 1 over 5x function. So that is how this function, let me write f of x, will look like. It is defined for all values except for x equals to 5. But you can see very clearly, as you approach 5 from both left side and right side, you approach a value which is minus 1 over 25. So this whole is at minus 1 over 25. So that is what you get. And I hope with this example you understand and appreciate how we're trying to find limit of a function which is not defined at the limiting point, right? And also you appreciate how an indeterminate form can be simplified and then we can find the limiting value, correct? Thank you.